Alright, what we're going to do today is a weak acid, strong base titration. And these problems are probably some of the hardest problems you're going to do in AP Chem. So let's try this. So you're going to start with 50 milliliters of your weak acid, acetic acid. That's 0.1 molar. And you're going to titrate it with 10 milliliters of NaOH, which is a strong base, and that's also 0.1 molar. And because this is a weak acid problem, you need your Ka value of acetic acid, which will be given in the problem. And for acetic acid, it's 1.8 times 10 to the negative fifth. Okay. So first off, what you have to do is do stoichiometry, and because NaOH is a strong base, it's going to dissociate 100%. So your equation is going to be OH minus, you don't need the Na because it's a spectator ion, plus your acetic acid is going to yield an acetate ion, and the OH is going to combine with the H to make water, H2O. So now you have to do stoichiometry to figure out how much of these reactants are converted to products. So first you have to find your initial values, then you're going to find out how much is left after the reaction. Okay, so to find these, you need to have these in moles. So to find moles of OH, you're going to multiply your volume by your molarity. So 10 milliliters is equal to 0.01 liters, and you're going to multiply that by 0.01 molar. And then same thing for this, you have 50 milliliters, 0.5 liters. Multiply that by your molarity. And then you don't have any acetate ion yet, and we don't really care about water. So your OH negative is 0.001 mole. Acetic acid is 0.005 moles. And then what we're going to do here is kind of a limiting reactant problem, only a lot simpler than a huge problem. You're going to take whichever one's smaller, subtract it from everything on the left side of the equation, and add it to everything on the right side of the equation. So we have 0.001 moles. We're going to subtract 0.001 moles. That's a 0. And then for acetic acid, we're going to subtract 0.001 moles. And that's going to give us 0.004 moles. Then we're going to add it to acetate, and that's going to give us 0.001 moles, and still don't care about water. Okay, so now we have moles, and then to do our ice table we need molarity. So what we're going to have to do is divide each of these by our new volume, which is more than 50 because we added NaOH. So the 50 mils plus the 10 mils of NaOH equals 60 milliliters, or 0.06 liters. So divide both these by 0.06 liters. And for acetic acid, you get 0.066 molar. And for acetate, you get 0.0166 molar. Okay. Now that we have our new molarities, I'm off the screen. Now that we have our new molarities, we can do our ice table. And the equation we're going to use for our ice table isn't this one. It's going to be our pH determining reaction, which is the equilibrium between acetic acid and H plus with the acetate ion. Okay. So initially, we pull these numbers from here. So initially, acetic acid, we have 0.066 molar. H plus, we have 0. And acetate, we have 0.0166 molar. Okay. So this equation, since we're adding OH minus, it's going to combine with this H, and it's going to push this to the right. So everything on the left is going to go down by X, and everything on the right is going to go up by X. And what we're going to have to do is solve for X, and that's going to give us our H plus concentration, which we can find our pH from that. So we have 0.066 minus X, X right there, and 0.0166 plus X. In the solve for X here, we're going to have to use our Ka equation. So Ka is equal to the concentration of the products over the concentration of the reactants. And we have our Ka value from up here, 1.8 times 10 to the negative fifth is equal to our concentration of H plus, which is X, times our concentration of acetate, which is 0.0166 plus X, and this is all over our concentration of acetic acid, which is 0.066 minus X. Okay, so at first this looks kind of hard to do, but since our concentration of X is really, really small, we can assume that these X's, we can just zero those out. So then you multiply your Ka by 0.066, then you divide that over, that you can solve for X, and X is going to be equal to 7.2 times 10 to the negative fifth. This is also equal to our H plus concentration right there. And then all you have to do is the negative log of your H plus concentration. That's going to give you your pH, which is going to be 4.14. And there you go. That is the pH of your acetic acid solution when you add 10 milliliters of sodium hydroxide. And that is probably the longest problem of AP Chem, and they're not fun at all. I don't know how to end this.